This is JavaScript. It's actually available for everyone on my website. So it's just basic, like I guess in Python you can do a more complicated version, but this is a more basic front-end JavaScript only. JavaScript only. JavaScript only. But yeah, we're doing development. Everything we do is eventually on BioniChaos.com. Someone was asking about music. Yeah, we have this music generation using hand gestures thingy that we probably can get up and running if you wish. If you wish. No, I can't show it in my camera, in the virtual camera feed. You can show it on the side, which you can see on the YouTube stream. Everything you talk about, the data set is very low. It's or non-existent. It's like a whatever n of one data point that you seem to base all your theories on. Oh, I heard this thing and this and that. Well, so far, everything you say is based on either no data points or... Man, I don't even know a theory. Show me, show me, show me. Don't tell me, don't tell me, show me. No, so you see, there's nothing. You can't show anything. You know, you have to... Right. That's called EEG. Yeah. Yeah, no, so yeah, keep going on that one. Well, how do you measure how do you measure the consciousness level? Like you can sedate. No, that's bull. You can administer like drugs with it, like... Who did? Penrose. Did he win? Was it for that? Are you sure you read it correctly? Right, now, okay, now you're closer to, yeah, so anesthesiologist, yeah. So why are we talking about it? Like, if you can't measure it, you can't prove it, you can't test it, you can't use it. So it exists in like a parallel universe. Well, if you can test it, you have to measure something. Right, man. Wait a sec. Yeah. Yeah, so we're developing this website. Go check out BioniChaos.com. Everything we do is available on this site. We probably won't be doing development today. We're still testing a few things. Testing, lots of testing. So if you have any questions about the website, do let us know. We'll probably just turn them into prompts for future development. That's the website link. Let me know if you wanted to jump into any of those applications. Currently we're testing that real-time amplification microscope thing. It's surprisingly working pretty well. People can't actually believe it's working, but it's doing pretty good. Let me know if you tried it out. I'll share the link for this one specifically. The link address. Yeah, what's called face blood. Yes, it's actually measuring your blood pulsating through the camera. How good is that? Sometimes it doesn't. It does even work sometimes. You have to still sit still, control the light in the room. What else? What else? Let's see if it's working now. It should be showing me 67, 68. Let's see if I still sit still. Can't even pronounce sit still. 63. 70, and my smartwatch showing 69, so close enough. Close enough. What else should we jump into? What else shall we jump into? Any requests? More than welcome. You can try any of it yourself as well. Sorry, I had to mute someone. Had to mute someone. And my microphone is playing up. It keeps putting it to, like, reducing the gain. What was the question? I did check the link. Could you explain which are the libraries you are using on this FaceBlood webcam tool? A webcam tool. Which libraries? Good question. You can see the source code on the page. You can tell me. How about you check the source code on the page and tell me what libraries are being used? There will be some basic stuff. It's all happening in JavaScript, so it's all front end. Just some very basic libraries. Wait, my settings. So let me know if you check the website, if you have any specific questions, do let me know. Is there a backend? No, there is no backend. It's all happening in JavaScript. Great question. We used to do things with backends. If you look at some of the older tools, they might have a backend, but the new ones are front end only, no backend. Front end only, no backend. And we are live streaming all the development. So there should be videos of me actually developing this tool. If you go into the live streams a couple weeks, last week, I think. Last thing, yeah, that's only JS. Very amazing. Yeah, we're doing all the development live on YouTube of these things, so you should see videos for each tool on the website. There will be a video developing it live, so it will be a live session. Some of it will be chopped up into smaller videos if there's something standalone interesting, but the stream should just have it all. So let me know if you wanted to jump into any of the other tools. This one was a recent addition as well. There should be videos on this. There should be videos of me developing it, me talking to AI, AI talking about it, like to itself or to me, or two AIs talking. All the combinations. All the combinations are there. But yeah, I'm happy to jump. We have a lot of optical illusions on the page. We can jump into any of those as well. They're good. Optical illusions are good because you can test LLMs. You can test how well they can code. I don't know if an LLM, obviously it's an open question, if an LLM can make its own optical illusion, like create a new one, one that doesn't exist. I'm sure it can, but made the versions of optical illusions. So they will be like essentially unique in a sense. Yeah, we have advanced EEG generators that are quite popular. This one doesn't fit the screen, so you have to go like 50% of the screen or something, and yes, you can change pretty much everything under the sun. There's more controls to it as well. More controls, more controls, more controls. Yeah, this one just runs a demo mode. That one runs a demo mode. Okay, everything we do is eventually available on this website, BioniChaos.com. Go check it out, provide your feedback. Otherwise, we'll be getting feedback from robots. Ideally, it's designed for humans, but we have no choice. Robots it is. If you tried the signal amplification microscope yourself and you have any suggestions as to how to improve it, they're more than welcome. I don't know how to improve it, so I don't have any good prompts. Maybe if you check the tool, you will have a good prompt. Otherwise, we're taking like physics simulations, turning them into web applications. So essentially gamifying biomedical data, that's the goal. Gamifying biomedical data is the goal. Gamifying biomedical data is the goal. This is not biomedical per se, but it's physics, which in turn can be biomedical. But you can choose your number of vectors, select your speed. It will try to replicate your drawing. It will try to replicate your drawing. So see how many vectors you need to do it. Obviously, for a simple drawing, you can get away with less vectors, 10 in this case. You can see how the things rotate on the screen. So it's just the vectors rotating. So it's essentially a good example of how FFT works without the maths. And FFT is used for biomedical data processing. So it is biomedical related. Well, I guess everything is biomedical related because you're looking at something on the screen, using your eyes, that's biomedical. Using your hand to control your mouse, that's biomedical. In this case, you can do drawing by using both. Don't know what that is. Does anyone know? Nothing. It's nothing. Just random. It's hard for humans to generate random stuff. Could you tell more about your goal and your educational background? Well, I got a PhD in biomedical engineering, so that's my background. That's my background. I was working on cochlear implants. and then using a cochlear implant to monitor epileptic seizures in epilepsy patients. Someone is asking why the BPM is so low, whatever. So the signal quality is mostly poor, so you need to actually stop moving. You need to control the light in the room, stop moving and stuff like that, then you can get a correct measurement. So currently my smartwatch is showing 60, 62. So let's see if we can reproduce that. Yeah, so it's locking up on 62, 63 if I don't move. So that's good, that's close enough. My watch is showing whatever 65. My watch is also fluctuating quite a bit. Yeah, you probably need to compare it to a chest strap ECG for better recordings. Better recordings. Signal quality. That's what we are all about. Signal quality. Yeah, so only compare it. So this measurement is from the camera. People don't believe it's from the camera, but it's extracting green light from the video footage and looking at changes in pixel intensity, in the green light intensity, and so it can essentially amplify the blood rushing through your head. So that's just done through the camera alone. And then I'm just benchmarking it against the smartwatch, which meant to be more accurate. But then the smartwatch should be benchmarked against something else, against the chest strap. Then the chest strap should be benchmarked against like a, Holter monitor, whatever, the 9 or 12 lead ECG, and so on and so forth. So it's all approximation of stuff, isn't it? Approximation. Holter monitor is like a clinical grade wearable, but you actually stick whatever 9 or 12 ECG leads around the chest and then walk with it. But that's normally recording for like 12 hours, 24 hours. No, it's normally put like across the chest because you want, there's a diagram. It's also how it's changing over time. It doesn't matter what it is, at a very given moment. There's a whole other diagnostic value that you can get out of long-term monitoring. That's why the Holter monitor you record, like in the lab ECG, you will normally record for like an hour or so. With a Holter monitor, you will record for like 12 hours, 24 hours. I'm thinking from a camera, we could do monitoring of how much someone have drank. We can do like an video image recognition that will try and estimate how many drinks you had. Like recognize, estimate, do like a prediction. So say, I don't know how many drinks you had, like 1 drink or 2 drinks or 3 drinks. Yeah, so I'll, from your video, can try doing like train a model, a machine learning. Train a thing to essentially estimate how many drinks someone had. And that would be an interesting project. I'm sure someone have done it before. I'm sure someone have done this before. If you have any questions or any requests for what we should develop next? Do you have any requests for what we should develop next? Do you have any requests for what we should develop next? Does rhyme, doesn't it? Some of the older tools might have a backend, which is something we don't do anymore. Trying to get rid of using a backend. Everything is should be working fine. If you simplify it enough, things do not have to be complicated. If you simplify it enough with just doing front end only. A comment to an older video, if we can do an expression, a facial expression detector. So apparently it was already done. It's running okay-ish. We'll trying it out. It's using face JS, what's called cell propagation. We had a particle motion simulation. We haven't touched that one in a while. If you have any interesting questions about anything on the website, we did this particle simulation. They're just bouncing around. Can control number of particles, speed. Can reset simulation. That's pretty much it. So how do you turn something like that into a cell simulation propagation tool? Yeah, we'll need an expert on that one. Yeah, right. So I'm saying you could go on this website, use a tool that will try and determine machine learning, whatever, to count drinks, without measuring the drinking motion or cans or whatever, but actually looking at your face, from your facial expression, because to begin with, yeah, I don't know, we can try. Maybe I can do it. I'm sure it can do something. It can apparently detect there are models like detecting your age. So that's actually probably relevant because your biological age will be different to your actual, health metric age. Because as soon as you keep drinking, your health estimated age, your age based on, like, say, if you had like 100 clinicians, well, right, but we need like a data, we need to put it in perspective. So we're talking about, like, say, 100 clinicians, medical trained, whatever, someone, guessing what your age is based on how you walk, how you whatever. So you can do it on camera, maybe just looking at your face. Yeah, so apparently before, a model was detecting me like 10-15 years older than I actually am, so that's quite unfortunate. Maybe if I shave or something. I don't drink. That helps. But, like, what follow-up questions do you need? What technique, like when you do cell simulation propagation, like what do you need? What do you need to know? Do you need a data set? Can we synthesize? The main question is, like, because if we can generate synthetic data, then we can generate it ourselves as well. If we need a data set, that's a whole different story, because then if there's a pre-trained model that we can use, there probably are, but yeah, if you can send a link to a pre-trained model, then we can use that. That would be interesting as well. What else could you do? So yeah, the obvious questions, so when doing cancer cell simulation propagation, it was like, are you targeting specific types of cells? Like how many, so what would you have on the front panel in terms of, so you'll have some sort of simulation, how cancer spreads, grows, whatever. What controls would you need? And is it based on existing data, or is it being synthetic data? So in theory, from Game of Life, you could what currently in the game, where's the Game of Life simulation that we had? Game of Life. Yeah, there's Game of Life. So if you haven't checked Game of Life, go check that one out. If you haven't seen it before, it will blow your mind. So that's a good one. Now in here we have, what do we have? Sand, water, rock, life. So can we add cancer? Is the cancer, we can add water. Can put some rock buffs. By the way, if we make like rock buffs like this, we can actually fill them with water and they create like an incubator. An incubator generates life. Can put water in this rock bed of rocks, rock of beds. By using your tool webcam-based, what about stress or anxiety estimator? Yeah, that's a good one. Again, how do you narrow it down? We need to narrow it down quite a bit. The question is, by using your tool webcam-based, what about stress or anxiety estimator? So that's obviously estimator. from the word mate, estimator, mater. Yeah, obviously that's something we would love to do. Something that we will love to do, but we need a targeted, like a specific prompt. Like again, what are we basing it on? What is stress? How do you measure stress? So your heart rate can be an indicator for stress, doesn't it? So there it is. You can measure heart rate. You can measure stress. Anxiety is a whole different thing. How do you measure it anyway? How do you measure anxiety? How do you measure anxiety? So the previous question was, so if we had the cancer cells, so can we add cancer to, we have water, sand, rock, life. Where there is life, there probably is cancer as well, isn't there? What's that one says? By using a tool, webcam-based, what about stress or anxiety estimator combines facial micro expressions / heart rate variability via webcam PPG. Well, this is webcam PPG. So micro expressions. Micro expressions like what? Like twitches in the face. Micro expressions. Oh. Yeah, I don't know. Pupil dilation and gaze tracking to estimate mental effort via webcam. So yeah, so that's great. Pupil dilation is great. We have a webcam pupil thingy going on as well. So this one will find your face wherever you are. Will find your face. Find your eyes within the face, obviously. Yeah, so that's overlaid. It will find your eyes within the face, and then within the eyes it will find the darkest bit. So you can actually adjust with this web app. You can actually adjust the darkest bit so it works better or worse. Depends how you tune it up for your own setup. I think it works better for one eye than the other. Well, considering it's a webcam, you have some eye tracking solutions that cost like an arm and a leg. Anyhow, yeah, so for, what did you say, for mental effort? Well, we need the mental effort, which we could use like optical illusions for. So essentially, we could use one of those optical illusions and increase the, what happened? Oh, on this browser, the speed actually goes to 0, which is good. No, because I was trying it on the now browser and the speed all the way down was not going to 0. So this, yeah, I don't know if you know this optical illusion. So it can be, yeah, now it's not tracking my pupil. It's not tracking my people. Why is it not tracking my people? Anyhow, I don't know if you know this circle illusion, optical illusion, which is did you say circle illusion? Yeah, it is a circle illusion, because it's these things go in a circle. I need to see if they moving in a linear fashion or not. Because if like two thingies. How about facial asymmetry and stroke screen? Quick pre-diagnostic tool for neurological assessment. We will need a baseline for that one. Because maybe someone's face is asymmetrical to begin with. You don't want to overdiagnose them, do you? No, it's not funny. I'm not joking about. Yeah, it's not funny. No, but it is funny that you can make some very basic mistakes and do quite a bit of damage. So anyway, had a subscriber as well, so thank you for that as well. Yes, so back to the mental effort. I was saying that you could, and there will be papers on all this, but just reiterating that you need to actually be able to change mental effort. You know, if you wanted to test your system, you know, that pupil dilation actually has an effect, well, then you need something to test it with. So how do you, I'm saying potentially you could use optical illusion, and you know, the harder or the easier it is to see the illusion. Well, we had a better one for this purpose. Maybe this chaser. Yeah, it's called lilac chaser. I don't know if you can see. Can you see a green dot there? If you do, oh, you have to look at the square in the middle. To look at the square, focus on the square. You should see a green circle, which is obviously not there. So I'm just saying, with the mental load, you can change your mental load by making the illusion like easier or harder to see. Maybe this, I suspect something like this was done. There will be literature on it. Brainstorming is great. You can measure your mental load during brainstorming. That would be nice as well. But how do you put like a number? How do you put a number to it? Hand tremor or stability analyzer. How it works: track small oscillations in head position when extended. That's a great idea. Was it done before? I suspect all of these things were done before. Once you start digging into things like that, you quickly discover that it was done like a million of times, and it's either it didn't work or it works so well that you know, it's available already for everyone. But yeah, some really good ideas there. Thank you very much. I think what was before we're talking about mental effort, I think my brain is mentally overloaded. But yeah, we have to turn it into prompts. How do you turn it into prompt and give it to a language model to actually develop the thing? And you can do it yourself. But yeah, let me know if you have any more ideas. We're happy to add them to the list. Turn it into a prompt. You can turn this conversation now into a prompt. You can do it fairly quickly. Maybe I'll try it next week. Yeah, I'll take your ideas. Let's copy the chat, give it to Perplexity or something. I'll put it in text editor first, because I have a whole list of prompts for like how to develop a web application. Temperature or fever indicator via thermal approximation. Well, you need a thermal camera then, don't you? If anyone's gonna send me a thermal camera, go for it. I can send you the specs of which one I want. Yeah, you could do a lot with thermal imaging. Can you extract the main ideas from this conversation above and give me like a title and then a short description of what the idea is? Yeah, lots of ideas. Love it. Even without an infrared camera, the webcam can detect relative skin temperature by analyzing the color distribution. Temperature of what? What's the of human body? The color distribution of the skin. Yeah, especially in the forehead and cheek regions. When a person's temperature rises, subtle shifts in redness and brightness occur due to increased blood flow. Okay, so how would it be different to PPG, like to this? I mean, I know it's different because you're extracting temperature out of it, but how is it like algorithm-wise different from what we're doing right now? And we'll add it to the list. Happy to add it to the list. Oh, this is from Dr. J. So it's good we have a real brainstorming session right now. Wow. Hey, can we add this more ideas as described below to the list above? We have 1, 2, 3, 4, 5, 6 ideas. 6 ideas. Temperature or fever indicator via thermal approximation, stress and anxiety estimator, mental effort estimator, facial asymmetry, and stroke screening, hand tremor, or stability analyzer. That probably, which one would be more promising? Probably the hand tremor. A cancer cell propagation simulator. Yeah, for the last one, the cancer cell propagation simulator will need an expert. So if anyone actually knows cell stuff, we're more than happy to make an application. Yeah, we're doing something with an expert before. We actually ended up with like a very large data set. It wasn't cancer cell, but it was related. Yeah, everything is related to everything kind of thing. Yeah, so it depends who is the expert and yeah, how you approach it kind of thing. But let's see, and then or regression model trained on labeled data, normal versus elevated temperature. But that has to be individual. How do you calibrate it for an individual? A convolutional neural network or regression model trained on labeled data, normal versus elevated temperature, learns to approximate temperature from RGB input. Okay, that's interesting. Yeah, very interesting. I'm just thinking it's either been done or it doesn't work, because it's like one of those obvious things to do. What do we have? Temperature or fever indicator via thermal approximation, stress and anxiety estimator, mental effort estimator, facial asymmetry for stroke screening. That one will need a lot of disclaimers. What else we've got? A hand tremor or stability analyzer. That's actually not too bad. It's not too chubby. Could do that. A cancer cell propagation simulator. Yeah, that last one. Yeah, there are probably things like that been done a lot. So we just leave it in the wish for basket. If we do have an expert who knows anything about it, let's say I think we could enhance accuracy by combining it with face detection and lighting normalization techniques. Yeah, so this tool right now could use some lighting normalization, and that's been done a lot. I've seen stuff like that. Yeah, we'll add it to the prompt, update the thing. Does hand tremor or stability analyzer could be used for Parkinson's tracking? Well, that's the thing that I was saying. We need a lot of disclaimers, because which one was it? The facial asymmetry for stroke screening. Yeah, so we would not be using any of those words. So we don't want to use like stroke or Parkinson's. Well, we can talk about it, but we're not going to be using it in the tool itself. So it has to be like independent from it. Yeah, because tremor, hand stability could be used for anything. When you doing a drawing or something, you need a stable hand. Surgeons could use a stable hand as well, couldn't they? But but once you mention Parkinson's, whatever you're suggesting, you can be doing like a diagnosis or something, and we do not want to go there. It's a shaky grounds. We have some surgical simulators. This cochlear implant insertion thingy, where you can actually insert the cochlear implant. If you actually use this tool, you can tell your parents that you are a surgeon. Because you actually inserted the cochlear implant into a digital inner ear. How good is that? If you use this tool, by the way, I'm happy to issue you a BioniChaos certificate. I'm saying I am a ENT surgeon now. A virtual one. With all the disclaimers, obviously. Do not touch any human patients. Yeah, so that's the kind of stuff I'm talking about that have to be careful about. When mentioning whatever Parkinson's, stroke, you have to make huge disclaimers because patients are quite vulnerable. You don't want to disillusion anyone in believing something actually works or helps or whatever. Technically speaking, logistic regression SVM for normal versus tremor, something like that. Really great ideas. Implementation, for me it's like implementation is key. It's like there's no shortage of ideas, and a lot of the bots can probably do it, if you turn it into good prompts. So the next thing, so now we have a table of like a title of the project. So based on computer vision biometric data, that's great. We have a title of the project and some description. Next column should be a prompt for whatever called web application development model, which is like a language model, to actually generate a web application. And we are happy to host it on our site. Yeah, the respiration rate idea is not bad, because you could use the same thing that I'm doing right now, the camera amplification thing, to detect motion. Yeah, so there are videos of it. So when there's a subject not moving, so like a baby in a crib or something, and then or sound asleep, so you can actually see the chest is being amplified because that's where the motion is. Yeah, someone is asking what simulations we're doing right now. So we're doing lots of simulations. This one is doing your heart rate monitoring from the camera, but then someone is suggesting respiration rate detection. So that could be using the same like amplification, but instead of extracting green light, you'll be amplifying motion. Yeah, so we're developing live all these tools that we make eventually we develop them live on YouTube. Then they go onto our website. Yeah, I wonder if wherever there is live, there is also cancer and viruses and stuff. So I wonder if you can take a basic game of life. Currently we have sand, water, rock live, obviously, because it's a game of life. But then we can add COVID, so add viral infections, probably be red something, a red viral infection. Oh, by the way, this one, so this is a special case of the original. It's not the original, it's a better version. Well, obviously I'll say it because I'm biased, but this one continuously generates life around water. So when you have water, you can see over here and there, this is like an incubator. So like build an incubator, be there, floating gardens of incubation. Floating gardens of incubation. Can make another one. Let's build it around here so we also break that silly pattern there. Fill it with water. Fill it with water. Boop, one drop. Oh, we have that incubator will be leaking. We don't want it leaking, do we? We can fill it with water. Well, now it's leaking on the other side. Let's fill it up. So yeah, so wherever there is life, there will be also all these other things. There will be viruses. There would be also tremor, viral infections, stroke. Respiration, the thing life should be breathing as well. It should look more like breathing as opposed to just like jumping around. But that's the thing with like the game of life is just such a simple algorithm. What's called emergent behavior, when you have very basic rules and life is emerging out of it. Well, that's an illusion, obviously, or like LLMs. It's also an illusion of intelligence, because we don't know what intelligence actually is. So, okay, so I have some ideas for a project. Let me know. We have some ideas for a project. Let me know what you think. So I'll just tell you what the ideas are, and we will go from there. So I'll have a temperature or fever indicator via thermal approximation, stress or anxiety estimator through camera, via webcam, PPG, or voice. We haven't done voice. Can you add like also voice? Can diagnose a lot of things from voice, can't you? Mental effort estimator, facial asymmetry for stroke screening, and hand tremor stability for Parkinson's. What do you think of those? And which one's better? Just choose one.
Those are interesting ideas. If I were to pick one with strong potential impact, I'd suggest going with a stress or anxiety estimator through webcam, PPG, or voice. It's highly relevant and useful for many people.
Sorry, say that again and expand on it.
Sure thing. I recommend focusing on a stress or anxiety estimator, which can analyze either webcam input, photoplethysmography, PPG, or voice to estimate stress levels. This can be valuable for mental well-being apps, wearable devices, or healthcare tools, helping users monitor their stress in real time.
Okay, so we know what it's helpful for. How would you actually... Well, what things do you need to consider? Like any ethical concerns?
When developing a stress or anxiety estimator, consider privacy and consent, ensuring users know how their data is used. Also, be mindful of accuracy. Misinterpretations can lead to undue stress. It's crucial to ensure fairness and avoid biases in your algorithms as well. Sure, for each idea, a temperature or fever indicator would need precise thermal sensors and calibration. A stress or anxiety estimator should factor in multiple inputs like voice and webcam and use validated models. A mental effort estimator would analyze cognitive load from voice or input patterns. Facial asymmetry for stroke screening would require robust facial analysis models. And hand tremor stability for Parkinson's would need fine motor control detection. Each has specific technical and ethical considerations. Let's start with the temperature or fever indicator. It's based on infrared thermography, IRT, which can estimate body temperature with moderate accuracy, sensitivity and specificity around 0.7 to 0.8. It uses facial regions, like the forehead, to calculate temperatures and detect fevers. A temperature or fever indicator involves measuring surface temperatures, often with infrared sensors, and applying algorithms to detect fevers. Key considerations include accuracy, calibration, privacy, and usability in various environments like hospitals or public spaces. Calibration involves setting reference points using known temperatures, like body temperature, 37 degrees C, and normal room temperature, then adjusting the sensor readings to match those known values. You also need periodic recalibration for accuracy over time, especially if the device is used frequently or in variable conditions. Proper documentation of calibration procedures is also crucial for compliance. Typically, you don't need individual calibration. Instead, you calibrate the device against standard reference temperatures, ensuring it's accurate for all users. Once properly calibrated, it provides consistent readings for anyone. Individual recalibration isn't necessary. Sure, stress or anxiety estimators, using webcam, PPG, or voice, require minimal calibration, mainly to ensure the input devices are consistent. Mental effort estimators need baseline data from users, but not strict calibration. Facial asymmetry and hand tremor tools also need baseline calibrations for accuracy, but not individual recalibration. Generally, once set up, these tools remain broadly applicable.
Okay, so that's perplexity. Is it talking nonsense or does it know what it's talking about? Hey, can you repeat the list of ideas that we had?
Sure. The ideas you mentioned: 1. A temperature or fever indicator. 2. A stress or anxiety estimator. 3. A mental effort estimator. 4. Facial asymmetry for stroke screening. 5. Hand tremor stability for Parkinson's. That's the full list.
Which one do you like best?
I think the stress or anxiety estimator is the most impactful, as it can help monitor mental well-being in real time for users.
Nah, that will be the hardest one to do, isn't it? Because how do you measure stress, really?
You're right, it's challenging. Measuring stress involves analyzing physiological signals, like voice tone, heart rate, PPG, or facial expressions, and applying machine learning models to interpret them. It's complex, but feasible with data and robust algorithms.
How about the tremor, the hand tremor?
Hand tremor detection involves capturing fine motor control using video or sensors, then analyzing movement patterns with signal processing or machine learning. It's simpler than stress estimation, but still requires careful calibration and testing for accuracy.
How do you calibrate it and how do you establish a baseline?
To calibrate hand tremor detection, use known movements, like steady hands or deliberate tremors, to set baseline motion levels. Then, apply algorithms to detect deviations from this baseline, indicating tremors. Regular testing helps ensure ongoing accuracy.
Any other technical issues? Can you also rate the ideas we had, dampen them by complexity?
Sure thing. Here's a rough complexity ranking from simpler to more complex. 1. Temperature or fever indicator. 2. Hand tremor stability. 3. Facial asymmetry for stroke screening. 4. Mental effort estimator. 5. Stress or anxiety estimator.
So we will add that list to YOLO. Wasn't YOLO trained on whatever, cats and dogs? So how's it gonna be relevant for tremor? I mean, tremor is just pixels. We can do pixels on the screen. You put your hand, it puts a thing around it. Puts the finger. It puts the things around it, and then you see the pixel variation. Motion, detecting motion from pixels or something. Why do you need YOLO? Why do you need YOLO? Why do you need YOLO? Right, YOLO for breathing. For breathing again, pixel amplification, like you're doing like a microscope, like we're doing here with the color, a green color, to measure blood heart rate. So we're doing again for pixels, for motion. I think. Hey, can you write a summary of the conversation we had? And also do the ranking. So do the complexity ranking of the original ideas that we discussed. A stress measurement. Oh, complexity now. Okay. High. A Parkinson motion and tremor detection. High to medium. A facial asymmetry detection for stroke. Medium. Why is that medium? The baseline for that would be crazy. What if your face is asymmetrical to begin with? A calibration standardization across tools. Ethical risk. That's right. What? Where did it get that from? Yeah, it's hallucinating on me a bit. Original ideas. Yeah, perplexity. Yeah, we got the ideas. We got like 6 ideas from memory. We'll put them in the list. We'll put like complexity. We'll prioritize them and make an out column for prompts. And we'll go from there and just give it to different LLMs to actually generate the web application, because we're not doing any coding. Well, not on this channel. And let me know if there's any final questions, and we call it a day for now. Thanks for the chat. The chat was amazing. And also, we had, what is it, 6 or 7 ideas, whatever. If you can rank them by complexity level, and also start adding a column for prompt, for a technical prompt for a developer with no code. Like, the text should have no code, but a prompt essentially for a developer to develop a web application, JavaScript-based, front-end only, no back-end web application. We will have a detailed prompt for it that we are using normally. Don't forget to smash this big thumbs up button. Needs more vectors, doesn't it? This one needs more vectors. A big thumbs up. Big thumbs up. Thank you very much. You can isolate exactly the chest shoulder region where breathing happens. Yeah, ROI. That's what we're doing for the BPM measurement right now. Regardless of body position or minor movement. Well, yeah, that's what we were trying to do here. Obviously can be improved. But yeah, there's kind of mixed thing. I still don't know why would you need YOLO. I don't know what this was trained on, but why wouldn't you just do pixel amplification and detection, more basic? Why do you need a model for that to begin with? Yeah, why can't it be done like this one with the bits per minute, where you essentially just monitor the changes in green color, so the RGB, and looking at the fluctuation of the green color to detect your blood flowing through the face. So same for chest amplification. You just do pixel by pixel type of analysis. Want you?